Okay, this is the next lesson in geometry. It's called rotations. Okay, so we've already done two types of transformations. We've done translations and we've done reflections. Now this is the third type. It's called rotations. Okay, so its first definition is a rotation, obviously, because that's the lesson. A rotation is a rigid motion. So again, it means the preimage and the image are congruent. They're the same shape and the same size. Okay, it's a rigid motion that turns a figure around a fixed point, which is called the center of rotation. To describe a rotation, you need to know the following. You need to know the center of rotation, which is a point. You need to know the angle of the rotation, which is a positive number of degrees. And you need to know whether the rotation is clockwise or counterclockwise. And it says here, unless stated otherwise, assume that the rotation is counterclockwise. Okay? So if I don't say which direction it is, just assume it's counterclockwise. For it to be clockwise, I'll tell you it's clockwise. Okay? So there's three rotation rules you need to know. Okay? And again, these are for counterclockwise rotations. Okay? If it's clockwise, I'll tell you it's clockwise. But these are the three rules for counterclockwise rotations. Okay? A rotation of 90 degrees counterclockwise is the following. XY maps onto opposite Y, X. A rotation of 180 degrees counterclockwise is XY maps onto opposite X, opposite Y. And a rotation of 270 degrees counterclockwise is XY maps onto Y opposite X. Okay, so again, those three rotation rules, those are for counterclockwise rotations. Counterclockwise. Okay, counterclockwise. And I said down here, a rotation of 90 degrees clockwise. If I ask you to do a 90 degrees clockwise rotation, just know that's the same as 270 counterclockwise. So rather than give you more rules, just know that 90 degrees clockwise is the same as 270 degrees counterclockwise. And 270 degrees clockwise is the same as 90 degrees counterclockwise. Okay? And in case you're wondering, why didn't I give you 180 degrees clockwise right there? Well, because 180 counterclockwise and clockwise are the same thing. So 180 is 180. Think of it as being like a circle. Okay? If I'm going halfway to a circle, it doesn't matter which way I go. Okay, so now I have 4 examples. Now we have 2 easy examples and then 2 difficult examples. Okay? The easy examples are the examples around the origin. So example 1 is around the origin. Example 2 is around the origin. Those are the easy ones. Okay? Whenever you want to rotate around the origin, you just use the rules from the first page. Okay? So example 1, rotate triangle BNX 180 degrees about the origin. So in the top row of my table, I'll put the rule, XY maps onto opposite X, opposite Y. Let's go in alphabetical order. Let's do B and X. Going to map onto B prime, N prime, X prime. So again, when it's around the origin, those are the easy ones. We're just going to use the rule. So B, vertex B is at -1, -2, -3, -4, 1. Going to map onto B prime, opposite of each. 4, -1. N is at -1, 2, 3, 4, 5. -5, -4. Going to map onto N prime. Little glitch there. It's going to map onto n prime, 5, 4. X is at -1, -2, -3, -2. The map onto x prime, 3, 2. So let's graph that. 4, -1. 5, 4. And then 3, 2. And let's connect them, and let's label the vertices. So B prime is 4, -1. So this is B prime right there. N prime is 5, 4. And X prime is 3, 2. Okay. Example 2, rotate triangle JKV 270 degrees about the origin. So the rule for 270 degrees will be XY maps onto Y opposite X. So let's go in alphabetical order, JKV. The map onto J prime, K prime, V prime. Okay, J is at -1, -2. Going to map onto, you're going to flip them and take the opposite of the new second coordinate. Flip them and take the opposite of the new second coordinate. So J prime will be -2, 1. K is at 2, -4. Going to map onto K prime, flip them, and take the opposite of the new second coordinate. So -4, -2. And then V is at 1, 2, 3, 4, -1. So flip them and take the second coordinate, take the opposite. Okay, so flip them, opposite of the second coordinate. Now let's graph J prime, K prime, V prime. These are going to overlap a little bit. Looks like. Remember, these are all rigid motions. To be the same shape and the same size. And let's label the vertices. J prime is -2, 1, so this is J prime. K prime is -2, -4, -2. And V prime is right here. Okay, so again, I said those were the 2 easy examples because those are being rotated around the origin, okay? So whenever you want to rotate a point around the origin, you just use these 3 rules from the first page. Okay, now, the next 2 examples are not around the origin. So, if the point of rotation is not the origin, you need to follow these 3 steps, okay? Just remember the acronym SRA, 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 okay? St. Ray's Academy, I don't know, SRA. Subtract the point of rotation off each vertex. Rotate as you would around the origin. Add the point of rotation back to the vertex. Okay? That's how we're going to do these. Okay, so rotate triangle DFX 90 degrees about the point 1, 2. okay? So it's not around the origin, so we have to follow these 3 steps, okay? So first, let me just copy down the 90-degree rotation rule, just so we have it above. For a 90-degree rotation, the rule is XY maps onto opposite YX. So it might be handy just to have that on the same page that we're working on. Now let's, I'll start with vertex D. I'll just go in alphabetical order again. Vertex D is at the point 1, 2, 3, 1, 2, 3, 4, 5, 3, 5. What you're going to do is step number 1. This will make more sense as we do a lot of them. We're going to subtract the point of rotation off each vertex point of the figure. Okay, that's step 1. Subtract the point of rotation off each vertex point. So we are rotating around 1, 2. So what I'm going to do is I'm going to subtract out 1, and I'm going to subtract out 2. We subtract off the point we're rotating around. So when I do that, it gives me the following. 3 minus 1 is 2. 5 minus 2 is 3. That is step 1. Step 2, rotate as you would around the origin. So let's use our rotation rule right there. This is going to map onto the opposite y, comma x. So -3, 2. That was step 2. Step 3, add back in the point of rotation to each vertex point. So we're rotating around 1, 2. We're going to add that back in. Add 1, add 2. -3 plus 1 is -2. 2 plus 2 is 4. And that is D prime. We're going to do that with each vertex. So let's do the next one. Let's do vertex F. F is at the point 1, 2, 3, 4, 1. Step 1, subtract off the point we're rotating around. We are rotating around 1, 2. So let's subtract out 1, and let's subtract out 2. That gives me 3 and -1. Step 2 is rotate it like you would normally, according to our rotation rule. XY maps onto opposite YX. So 3, -1 is going to map onto 1, 3. Okay. And our last step is to add back in the point we rotated around. So we're rotating around 1, 2. Now we got to add that back in. Plus 1, plus 2. And that gives me 2, 5. That is F prime. Okay, so we got D prime, we got F prime. Now we have to do the final vertex. Let's do X and get X prime. Okay, so X is originally at the point 1, 0. X is at 1, 0. Step 1, subtract out the point we're rotating around. We are rotating around 1, 2. So we're going to subtract out 1 and subtract out 2. So that gives us, right now we are at 0, -2. Now we're going to rotate it as we normally would. So remember, our rule above is XY maps onto opposite YX for this problem. So opposite YX would be 2, 0. And then add back in the point you're rotating around. We are rotating around 1, 2 for this problem. So add that back in, and we get the final answer. X prime is at 3, 2. So now let's graph D prime, F prime, X prime. Okay, so D prime is at -2, 4. F prime is at 2, 5. These might overlap a little bit. 1, 2, 3, 4. It's okay. It's okay if they overlap. And X prime is at 3, 2. Let's connect those. And let's label the vertices. So D prime is negative 2, 4. This is D prime right there. F prime is 2, 5. It's F prime right there. And X prime is 3, 2. All right, we got one more like this. This one is also rotating 90 degrees, about the point negative 4, negative 2. So let's write the 90-degree rotation rule up top. Just like we did in number 3, just so we have it on the same page that we're working with. XY maps onto opposite Y, X. And again, all of these are counterclockwise unless I actually tell you clockwise. So this one's counterclockwise. If I tell you clockwise, then you do clockwise. Otherwise, just assume it's counterclockwise. So let's start with vertex L. This one's going to be a little tricky because you're rotating around negatives. Okay, L is at 1, 2, 3. 1, 2, 3, 4, 5, 6. L is at 3, 6. Okay, so step 1, subtract out the point you're rotating around. Let me just make sure I did that right. Yeah, okay, 3, 6. Step 1, subtract out the point you're rotating around. So subtract out negative 4 and subtract out negative 2. But since you're subtracting a negative, it's really like you're doing plus a positive. So plus positive, plus positive. So that gives you 7, 8. Rotate according to the rule. So 7, 8 maps onto negative 8, 7. Then add back in the point that you're rotating around. So we're going to add back in negative 4 and add back in negative 2. So plus negative 4 plus negative 2. Now this graph, this is a big number, but it is going to fit on a graph because our graph goes up pretty big. Okay, good. So negative 12, 5. That is L prime. Now let's do M. This one's tricky because of the negatives. M, vertex M is at 1, 2, 3, 4, 5, 6. 6, 2. Double check that. 6, 2. Step 1, subtract out the point you're rotating around. So subtract out negative 4 and subtract out negative 2. Okay? So minus negative 4 minus negative 2. You can make the minus negatives plus positives. So right now we are at 10, 4. 10, 4. Rotate it according to the rule. So for 90 degrees, opposite Y, X. So opposite Y would be negative 4, 10. And add back in the point we're rotating around. So add back in negative 4, add back in negative 2. Going to give me negative 8, negative 8, positive 8. That will be M prime. And lastly, N. So N is at negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. 1, 2, 3, 4. Double check. 1, 2, 3, 4, 5, 6. Negative 6, 4 for N. Subtract out the point you're rotating around, which is negative 4, negative 2. Again, same process. Minus negative 4, minus negative 2. Make those each plus positives. So negative 2, 6 right now. Then rotate it according to our rule above, opposite Y, X. Negative 6, negative 2. And then SRA, add back in the point we're rotating around. So add back in -4, add back in -2. It's going to give me -10, -4. That is N prime. So now let's graph L prime, M prime, and N prime. So L prime is at -2, 5, -12, 5, I mean. Just double check that one more time. Good. M prime is at -8, 8. And then N prime is at -10, -4. And let's connect those and label them. Now remember, these are all rigid motions. The pre-image and image should be the same shape and the same size. Boom. So this is L prime right there. This is M prime. And that's N prime. Okay. So again, you have to be careful. If you're rotating around the origin, those are straightforward. Just use the rotation rules on page 1. If you're rotating around points that are not the origin, then you have to follow those 3 steps. Subtract out, rotate, and then add back in. SRA. And that is the end of that lesson, which was rotations.